Okay, so we have section 3.2, question E22, and we have something about the body mass index, which the calculation is given here. You can calculate yours if you're interested, and also connection with blood pressure potentially. Looks like we do have a source here, so these are actual data. And if you want, figure out your BMI and actually calculate the percentage of males, if you want, well, if you're male, figure out what percent of males with your BMI have hypertension, or at least the prediction. But the real reason I chose this is because I want to show in some of the technology here. So it says use your technology to find the equation of the least squared regression line for males round to 2 decimal places. So what does this mean, use your technology? It means you can use a graphing calculator, you can use Excel, OpenOffice, whatever you want. I'm going to go through it with Excel, and you may wonder, how do you know how to do this kind of stuff? Well, I'll get to that right at the end. There are some Wiley tips on how to do these things. So I'm going to slam that over to the right, and so I can still see this chart here. And I'm going to pull up Excel. Let's do this one. I'm going to open a new file here. Okay, and slam that to the left. Now it doesn't really matter where I start my chart, just for kicks I'm going to start here. And make it a little bigger so you can hopefully see. And then I'm going to enter the data. Now I don't have to enter all the data just because I just want the males. So I need this BMI and I need this. It's easier if you arrange it in order of the X and Y that you want. So I'm looking here, what's my X and what's my Y? Well, I'm predicting percent of males with hypertension. So that's my Y. I'm using BMI, so that's my X. So I like how these are playing out. So now I'm just going to enter the values of the BMI. Now they do actually have all this text available in data format already, sometimes in Excel, sometimes in text that you can pull into Excel, and I'll show you where that is also. In this case it wasn't too bad. So once I get all those entered, and I do want to make sure that my X variable, my independent, is coming first here. That will make a difference. I'm going to highlight everything, go up to Insert, and get on Scatter Plots, Scatter. Okay, and here I get this scatter plot of my 4 data points. This is actually part of the key. Once I get that, I'm going to look and see if I see any major outliers. I may just double check to make sure I inputted the data correctly, but it's all seems reasonable. And even if there is an outlier, it could be correct. I right click on one of the data points, left click on Add Trend Line, and I realize you can't see this very well, but the very last 2 options give me Display Equation and Display R-Squared. That's what we'll use most of the time. I'm going to drag it out to the white here so I can see better. And this is giving me my regression line. So you can see they've drawn that line as a segment here. And then they give me the equation for that. One reason they do only draw the segment and they don't continue out drawing the line, and I like this, is that they don't want to extrapolate. So when you do have a scatter plot and you're coming up with a correlation and looking at your line of best fit through there, if you continue out beyond the points, you give this illusion that you know what's happening out here for the males with BMI of 20 or 40 or 50, 60, when you really don't have any data to support that. So going beyond your extreme data points is not a good idea. So here we're looking for the regression equation. We can see 3.335. We want 2 decimal places, so we're going to put 3.334 as our slope. And then we have negative 65.257, which we're going to round up to 0.26. Does this line contain the point of averages? Well, let's find out. So I'm going to just get rid of my chart there, and I need to get the averages. Now what I can do, if I just highlight these, and okay, I know this isn't going to be very visible, but come on. Okay, so it's making assumptions of what I want, even though I don't really want it. So when I highlight cells, at the bottom it'll give me an average, count, and sum. So I can see my average X value there is 27.5. For the males, I'm going to highlight them, and the average is 27 or 26.48. And here's something, if you do something wrong, Control Z is your friend. So 26.48. So this is my XY value. Now, is that on the line I came up with? Well, I'd have to plug in the 27.5 times 3.34, subtract 65.26, and I should indeed get something around 26.48 because that point really is on the line. Incidentally, if you don't have Excel, you can plug in a formula here, equals average, we'll usually do it, and then a parentheses, select all the numbers, close parentheses, enter, and I can drag that across in most spreadsheets, and notice that that did give me the same averages that the Excel shortcut did. Okay, so use the equation to predict the percentage of males with BMI 25. So we're just putting in 25 times 3.34 minus 65.26, and we'll get out 18.2. They did round to 1 decimal place. Keep an eye on that. And should this line be used for predicting the percentage of males who have BMI 35? Now, why would they even ask that question? Well, that's getting into what I said about not going beyond the data that we have. So looking at BMIs here, 35 is higher than anything that we have in our data set. So we're really in the danger zone here, but because it's close enough to our highest point, they're saying, yes, this is okay. Again, this is the type of question that I do give extra points at the end of the course to account for this, because there is some subjectivity here. Certainly it would be okay for predicting anything within this range. Certainly it would not be okay for things like BMI of 10 or BMI of 50, 60, way beyond our data range. This one's just above, so we're going to allow it in this case, although I think no is also a defensible answer because 35 is outside of this range.